Hello guys. So today we have another scary looking problem. So if you read the problem is basically presenting an equation of velocity as a function of time, and basically it has all these mumbo jumbos over here with E and K, and admittedly at first it does look intimidating, and it would be if we were studying physics, but luckily we are just studying simple calculus at the moment. So let's just read the question before we judge it. All right, so it has given us this monstrous equation, and over here it's basically defining that m naturally is mass and k is the air drag. If you don't know what air drag is when an object is falling down, it's the air resists it. The air works against it. That's the air drag. And v0 is just v initial, so the initial velocity, and they are all given down here. So what it's asking, that this is the key to answering this question, is understanding it. So it's asking, calculate the terminal velocity, so the final velocity. So the term terminal velocity seems, maybe if it seems unfamiliar, it's basically that when an object is in free fall. So when an object is in free fall, there are forces. So there's gravity pulling it down, and then there is drag kind of working against it. And at some point, velocity will reach its constant state, and that is called the terminal velocity. So the velocity will just be at a constant rate, and basically the gravity and the drag, or the forces balance out at that state, and that is terminal velocity. And if you have studied this in physics and you know physics, you must be on top of the moon right now, because you're just gonna figure this out instantly, saying that, hey, okay, V equals just the gravity, and this 9.81 is just referring to gravity, uh, times the mass and divided by the drag, and that should just give you the terminal velocity. But if you haven't studied physics, you gotta think about this question a little bit. This equation still holds true, but let's think about what happens. What happens as, let's say, perhaps we are in free fall for 10 seconds, and let's say that continues on even for 100 seconds. So we concluded that at some time the velocity will be constant, and that velocity we call v terminal. And theoretically thinking, v terminal is basically approaching v infinity, right? It's say as time is just moving on towards infinity. Let's say you're free falling, not to Earth, just I guess towards a black hole. I don't know what happens down there, but you're just gonna free fall forever. I mean, your velocity is not gonna move. It's not gonna change after a certain point. You're gonna hit terminal velocity, and you're gonna just go at that constant rate as as you travel through time. And if you're traveling through time toward infinity, you're just approaching v infinity. And we can think about this concept. Let's just plug in the values that we are given into the equation. So okay, so vt equaling gravity times the mass, which is 9.9 kilograms, divided by the drag, which works against these two, which is, that's why it has a negative notation. All right, that plus the initial velocity, so negative 2.3 meters per second times E. And this is actually, so this is quite challenging to derive this equation if you're actually studying physics regarding terminal velocity and drag force. But it's quite simple in our in this problem. This problem has made it quite simple. And then we have k, which is again negative 1, 1 times t. And the whole thing is divided by m, which was 9.9. And then we have plus again gravity times 9.9 divided by k, which is negative 11 times e to the power of k times t divided by 9.9. Okay, so now that we have plugged in everything, so you notice the question is hinting us to take the limit as time is approaching to infinity of vt, this equation. So what we are really essentially doing is taking the limit as time is approaching to infinity of this equation. So this is what we are doing again. And the derivative of vt at constant, so when it's constant, then the derivative is just 0. So when it's constant, there is no change. Like that means that the velocity has reached its terminal velocity, so that is equivalent to v infinite, which is equivalent to v term, as mentioned in the question over here. What we essentially need to do, we need to replace every single time we see a t in the equation of v with 0, because the constant change is just 0. If you take derivative of this respective derivative, it's just 0 at that moment. Well, if you want to take the value for terminal velocity, and this one would also be 0 because it has t. But notice this term, or rather in the original equation, that term, it has no t. And guess what? Turns out the physicists were right. So if you want the terminal velocity, you could just use the gravity times mass divided by k equation. And to answer our question, basically, so let's just replace all the values. So 9.81, and the mass was 9.9, and the drag force, I believe, was negative 0.11. And if you plug that into the calculator, you should get an answer. It should be a negative answer of negative 882.9 about. So that would be the answer. All right, thank you.